Hello, Pre-Calculus student. This video is for chapter 4.7 Logistic Model. So we have learned about exponential growth, exponential decay. Especially for exponential growth, we know that if something is growing exponentially, it basically start from A or 1, right? Grow like forever. So like a continuous increasing, just like linear is continuous increasing. But in real life, if this is about like I think money, maybe it will grow in depth in infinitely until you take it out. But for like population, there will be a case where you grow too much, the resources to sustain the growth is not available. So the population actually will not go on forever, but at a certain point it would decrease. So this kind of model can be modeled by something called the logistic model. And then the highest number that the population can increase to is called the carrying capacity. So these models normally would have something like, okay, in the beginning, it has just like an exponential growth, but then at a certain point, we call it the point of inflection or point of maximum growth, it would kind of decrease slower until it hit the carrying capacity where the population will not grow across it. And the model to model this is like this, is y is equal to, or the future value is equal to c, which is the carrying capacity. Like the largest number that you can reach is c. 1 plus a e to the negative bx. The individual value does not show up here. A is actually a initial value. We call it, so this a is different from the other a that we have is p y0, no, is c minus y0 over y0. So the initial value is y0, and b is the logistic growth constant, which is the logistic growth rate in case there's no what is it called, no constraint. So if under the normal circumstances, y should be y0 e to the bx, right? It should be like that. But because of a resources constraint, it would have a carrying capacity, and the model would be c over 1 plus a e of negative bt. A you have to calculate by finding c minus y0 over y0. So you will learn about this in more details in calculus. So for the time being, let's just use this logistic model that is given to us that models an influenza pandemic. Okay, so first is how many people have the flu in the beginning. So in the beginning, so if you want to do y0, so you would set that would be f of 0. So it would be 2000, 1 plus 199 e to the 0. E to 0 is 1, so it's 2000 over 1 plus 99 is 2000. So that's equal to 1. And you can see that this A that we have was, how do we get this? Was 2000 minus 1 over 1 is 1999. So that is one person has the flu. How many people in the long run? So that means in the long run is when x approaches infinity, e of negative 0.7 and an infinity is actually equal to 0. Okay, so because what happened is e means 1 over, right? 1 over e of 0.7 and infinity. So you have 1 over infinity, that would be 0. So in the long run, so you would have it would reach the carrying capacity. So you can think of it like this, and you plug it in, it will be 2000 over 1, that's 2000 capacity. But if you actually want to plug it in, that's how you do it. It's the top value, whatever that shows up here, 2000. How many people have the flu in day 10? So that would be f of 10. We'll just use it. 2000 in the long run. This is the carrying capacity. 1 plus 1999 e to the negative 0.7. Is it 0.7? Negative 0.7 times 10. So put in the calculator, and remember the bottom you have to parenthesis that when you put in the calculator. Turn on 2000 divided by 1 plus 999, 1999. Go back. Delete. 1999 times second ln e to the negative, remember, is 0.7 times 10. Close. Delete. I think we can close this way. That would be 7.8.5. That means 7 point, round to the nearest number, 709. So after 10 days, 709 people would have it. So this is, I just need you to get to this formula, how you can use it. So this is a formula for logistic model. It's C over 1 plus A e to the BT. And the important thing is the top value here, when the bottom is 1 plus something, is the carrying capacity. In the beginning, this would be equal to 1. So that would be how you find Y0. Okay. So maybe we can say Y0 can be equal to initial, this is 0, C over 1 plus A, right? We can do that too, because e to the power 0 is 1, C over 1 plus A. But to find Y0, to find A is C minus Y0 over Y0. Okay, so for this course, the main focus is how you can use this model, know about this model, that for exponential increased growth, there is an alternative where when resources are limited, you can model it by logistic model and use the logistic model for prediction, as well as knowing the carrying capacity in the formula.